Now that you have gone through my previous video, you know what a custom token authentication is for Web API. In this video, I'm going to explain what JSON Web Token is, and I'm also going to implement a custom JSON authentication by using a authorization filter so that we can truly understand what a JSON Web Token. And then in the next episode, I'm actually going to implement the JSON Web Token authentication utilizing what's already built in ASP.NET Core. If this is the first time you watch my video tutorials, my name is Frank Liu. I am creating weekly video tutorials covering every aspect of software development. This particular series is about Web API. In the first part of this series, I'm going to cover every technical aspect of Web API, and then in the second phase, I'm planning to create actual Web APIs, endpoints, and use them in different type of applications. If you like my video tutorials and like my teaching style, please consider subscribing my channel and hit the bell. First, quickly go over what we have talked about in the previous episode. So this is a custom token authentication scenario that we talked about in the previous episode. The client will first authenticate against the token manager, and then the token manager will generate the token and return the token to the client. From every subsequent Web API calls, the client will call the Web API with the token, and the Web API will then verify the token against the token manager, and the verification result is returned, and if it's successful, then the API result is also returned. This is all good, but what if we want to scale out, or if we have different endpoints of Web API, we want to do single sign-on, then every Web APIs will need to talk to the token manager to verify the token. So that's a little bit overhead that we need to cover there, and a little bit more traffic. So what if we can do this? Still the same thing, we're going to authenticate against the token manager, and then we'll generate the token, we'll return the token, and then we'll call the Web API with the token, but here we're going to verify the token right within the Web API. And then we'll return the API result if the token is verified successfully. So then we don't need to verify the token against the token manager. The token manager actually becomes a authentication endpoint where it will just authenticate and generate the token. It doesn't do anything else. JSON Web Token will help us to achieve this. But before I go ahead and explain what JSON Web Token is, let's take a look at this scenario where we authenticate against the server providing our credentials and see what happens there. So when we have a user interface that input username and password and then click on the login button, what happens next is that the username and password is passed to the server side, and then the server side will hash the password with a key, pair that hashed result with previously hashed password for that particular user in the data store. Right, so this is because hashing is a one-way process. You can't revert the hash result to the clear text. So it's not going to take the username, look for the hash password, and then decrypt that password, and then compare the password the user provided with the decrypted password. It will not do that. It will actually take your password that you provided and then hash that with the key, with the same key that was used to generate the original password that's stored in the data store. You take that same key and generate the hash password and compare the hash password with the previously hashed password that is stored in the data store. So this is the process that our credentials are authenticated against the server. Keeping that information in mind, when we generate the token, we take the user information, we take the key and pass that user information with the key into the hashing algorithm, and then generate a hashed user information and take this whole thing as a token. Then what happens is that this whole process that I just demonstrate it, right? Taking the user information, take the key, going through the hashing algorithm and generate the hash process, hash user information. That can be repeated without relying on a data store, because the user information kept as a clear text. Well, it's not actually clear text in JSON Web Token, but to explain what it really is, let's assume that user information is a clear text, hashing algorithm is a clear text. Then when we pass that user information going through the hashing algorithm, then we can generate the same hashed user information every single time. So in order to verify this, we just take the same user information going through the same hashing algorithm with the same key. Then it will always generate the same hash user information. Then we can use the newly generated one with the previously generated one that is already inside the token and compare them, and then we can know whether the token is valid or not. Of course, that user information in the middle also contains the expiry date of this token so that you don't always have this token. So the token is safe. Otherwise, people can get it and use it if the token is valid forever. And this is called JSON Web Token. The only difference is that JSON Web Token is encoded with base 64. With JSON Web Token, we achieve the self-verification benefit. The client can talk to different Web API endpoints on different servers as long as all of the servers share the same key. Then they can verify the JSON Web Token by themselves. They don't need to talk to the token manager or the authentication point anymore, right? So the token manager here will purely become a authentication endpoint that generates the token at the same time. How we can implement a custom JSON Web Token authentication by using the MVC authorization filter, which we used previously in the previous episode. We used the authorization filter. We implemented a custom authorization filter for a custom token authentication scenario. This time, we're going to create a custom authorization filter, and then we are going to verify JSON Web Token. Let's get started. Just a quick self-promotion. I have created a complete Blazor course where you can learn ASP.NET Core Blazor application framework step by step by creating a e-commerce web application with Blazor. And not only that, I will guide you to implement this application with clean architecture. One of my students who purchased my course and came back to my YouTube channel, and he said that, "Thank you, Frank. I am beyond happy to finally fully grasp clean architecture. I read the book and it clicked a little, then took some classes that didn't use it, and it threw me off. Your class fully fleshed it out. Just great." So if you are interested in learning the latest ASP.NET Core application framework, Blazor framework, go ahead, click on the card above. I have a YouTube video where I'm sharing the first 2 sections for free, and then decide whether you want to purchase it or not. The link to the full course is in the description area below that video. All right, let's go back to today's topic. So previously, we implemented this token manager that has 3 functions. It authenticates, it generates a token, which is nothing but a GUI. It has an expiry date, and then it verifies the token. Right? The token is stored in memory, and then this token manager is dependency inject, and the lifespan of this token is singleton. Right? It's always there. That's why we can verify the token. Right? And then this token manager is used in the authentication controller for authentication purpose, and also it generates the new token by calling the new token method. And also this token manager is used in the token authentication filter, which is a filter that implements the authorization filter and attribute and derived from the attribute class, and it verifies the token by first take the token from the header of the HTTP request and then verify the token by calling the token manager.verifyToken method. Right? This time we're going to change the token manager. We're going to update the token manager so that when it generates the token, it will generate a JSON web token. And then when it verifies the token, it will verify the JSON web token. The difference, you will see that we will not need the token in the memory, right? Because we're using the memory as a mock database. We're mocking the database with this. We will not use that anymore. All right, let's get started. First, we need to add a Nuget package that enables us to create and verify JSON web token. All right, so I'm going to right click on dependencies and manage Nuget package right here. And then I will go to browse JWT. It's first one that we are going to install. And with that, we are going to delete this and we don't need to initialize it. And authenticate method, we're not going to change. We're going to hardcode the admin and password right here. It's for demonstration purpose. But here, when we generate the new token, this is the place where we are going to do it a little bit differently, right? So in the in here within the class, we are going to use we're going to declare a token handler, and that's going to be a private variable, which is type of JSON web token security token handler. Security token. This comes from that package. Right, so we're gonna call it token, and I'm gonna control dot to import the namespace, and this one we're gonna initialize that, and also we are going to have a key. We're gonna hardcode a key here. Right, usually the key will come from a configuration file like the app settings.json. Here I'm gonna just hardcode it so that it's easier to understand. So a secret, and then we'll also want to initialize the key. Encoding dot, okay, let's do a control dot import dot namespace. It has to be a 32 character long for a secret key. Hash the user information by using the HS256 algorithm, right? So I'm just going to type in 32 characters, right? So I'm going to say 32 Ks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, so 32 Ks. So then we have a secret key. Now, when we generate the token is to create a token descriptor. The reason why we need to do that, if we look at the token handler, it has a create method, and this is the method we're going to use. It takes a token descriptor. Now we are going to create a token. And this is going to be a security token descriptor. Here we're going to provide some information. So the user information is going to be in the subject. You can see that it says gets or set the claims, right? So this is in the subject, and I'm going to provide the claims. Instead of having this, I'm just going to delete this and then control dot import the namespace for the claims. What is a claim? So a claim is basically the user who says, you know, my name is Frank Liu and my email address is blah. So basically the claims is user information. So let's simplify the teaching process. I am going to just create just one claim, which is just a name. And then I'm going to say the token is going to expire 1 minute later. And the token has to be, the expiry date has to be UTC time, right? So I'm gonna say UTC now, and then we're gonna specify the algorithm by say signing credentials equals both the algorithm as well as the key. And what it takes is a new symmetric security key. Second parameter is the algorithm 256 signature. So with this descriptor, pass this to create token. Create token will know what the information is, like what the user information is, what the expiry date is, and algorithm is exactly as well as the key, right? So it's all the information that we need for creating. So we need the user information, we use the key, the user information, and the hashing algorithm. So three pieces of information that we need, right? So the token descriptor provides all three information and then pass that to the create token method within the token handler. So the token handler can actually create the token. So here we're gonna pass the result to a variable and we're gonna call it token. This token, the previous code, so this token is a security token, right? It's not a string, but we want to, this time we actually want to return a string, right? So to do here is that we are going to say, JWT token, let's call it JWT string equals token handler. Token handler has another method can help us to write. So pass the token, and then we're going to return this JWT string. So now we have this JWT token string. To verify the token, what we need to do is, well, first we'll clear this up, and then we are going to use the token manager. Token manager also has another method called validate token. So we take that token, the token that to be verified, and the second parameter is validation parameters. So we're going to create that validation parameters, token parameters, and it will say, validate. Are we going to validate the key? Right, we're going to validate the key. That's when we validate the signature. Are we going to provide the information in order to validate it? Do the same process, like I have demonstrated in that slide. Issuer signing key, we need to provide that information, and then are we going to validate the lifespan, the lifetime of the JSON web token? Yes, we have to validate that. Otherwise, the token will always be valid, provided the same token is passed back. We're not going to validate audience. So just some extra from that. You can choose to validate. You can choose to provide the audience as a string and issuer as a string. Then you need to validate the audience and issuer. But in this case, we're not providing the audience and issuer, so we're not. And here, last but not least, we're gonna say clock 0. This clock skew thing is kind of an offside of time that you have to set it to 0, otherwise it will not validate. Like the default lifetime validation will work in a very weird way. Right? So we're gonna set it to 0 so that it will work. And then it will take a output parameter. So don't worry about what the purpose of the output parameter. I'm gonna call it validated. Right? So we're not going to use this validated token for anything. If the validation is success, it's going to return the claims. Right? What is the claims? I've explained the claims are basically just user information. Right? So if the token is successfully validated, it will return. Right? And here we can actually, if you hover over this, you can see that it's returned us this principle. And if the validation fails, it will actually throw exceptions. So that's it. Look, we are not using, we're not using a data store here, right? So this one is actually, let's delete the whole thing, properly defined. And in order to use it, let's go to startup, minimize that, and come over here, and we create it as a singleton. But now that we don't need it as a data store, right? Because I explained in the previous episode that if you want to mock the database, you always have to do the dependency injection as that will kind of mock the database. But because now we are using JSON web token, which is self-verification, right? Which can do self-verification, then we can just say add transient, right? Then now we need to go to the token authentication filter, and we're gonna see that here we dependency inject the token manager, and we take from the header, right? So here we take, and now we verify the token, right? So the return is not a Boolean anymore, so we can't do that anymore. So we have this result variable here. So then what we need to do is we're gonna do a try catch. And then here we're gonna say, result is false. Cut this over here, say unauthorized. Then the second parameter can be either an error message. So it's easier to do exception to string here to provide the error message. And then over here, if the result is unsuccessful, then we're returning unauthorized object result. All right, let's give it a test. And again, this is based on the previous episode where we implemented a token authentication filter as part of the filter pipeline, right? So the authorization filter interface that we implemented, this is one of the first, it's actually the first filter that will be executed inside the MVC invocation pipeline. It's also called filter pipeline. If you haven't watched the previous video, please go ahead and watch the previous video. You can find it in the card above. Click on that information button on the top right corner. You will see that. So I'll go over that very quickly, that in order to use this filter, we have to use it to decorate either a controller or a particular method to safeguard either the whole controller or a particular action method, right? So in this case, in the previous episode, we used the token authentication filter right here in order to safeguard every single action method inside the controller. Again, this way of implementing versioning may not be the correct way to implement. I was using this in the perhaps 2 episodes before for demonstrating the resource filtering in the filter pipeline. All right, so let's give it a test. Running the Web API application, it will run as a service and you will see it once it pop up. All right, so we have this. I have brought up Postman. We can use it to trigger our API. In here, first of all, we need to call the authenticate controller, right? So this one doesn't have the filter applied. So this one is anonymous, allows you to access it anonymously, right? According to the routing mechanism, we'll access it by root/API/ the name of the controller, which is authenticate. Here we didn't say anything, so this is the HTTP cat. So by default, we don't need to provide anything. So it's going to be API/authenticate, and it's going to be this one, authenticate user, right? User password, because this is model binding. Your parameters in the URL has to correspond to the parameters in the action method. Here we have user and password. That's why the URL has to be user and password, PWD. So here I have admin and password, and that's exactly what we are expecting because we hard-coded admin and password, and this will give us a token, right? This is a JWT token. We can go to the JWT.io, and if we go to debugger, we can copy and paste our token over here, and you can see that it's actually, you can see the format, right? The first part corresponds to this is the header, and this is, so this is the HS256 algorithm, and the type is a JWT token. And the middle part, the purple part, this is the payload, which is the user information, right? Technically, it's called payload. And then we use the key that we have, which is 32Ks. Remember, I used 32Ks. Using this algorithm and generated the signature. It says invalid signature because I didn't provide a key. So the process is like this. So first you clear this, and then you put in your key, right? Let's say I put something else. And then I come over here and I copy and paste my token, right? And then it says invalid signature, right? So in order to see whether it's valid or not, let's clear this, and then let's put in 32Ks, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 20, 30, and then I'll add another 2K, okay? And then And then I'll go over here and copy this key again. And we'll come over here and we'll say copy. And then it will say, you know, signature verified, right? If I delete a key, well, you can't see. We'll delete a key here, or let's change this, right? Then this is invalid, right? Again, this is the algorithm, and this is user information, and the user information will be hashed using this algorithm and generate the signature, right? So this is why it's self verification. It can verify itself by taking the payload, the user information, going through the algorithm and generate a signature and compare it with the original signature. Okay, so we need to regenerate this because we have a timestamp. If we were to just use this, let's go over here and let's go to our header, and then let's remove this and then paste this in. So this one is the one that just generated, but it was way more than 1 minute. Remember that we gave the expiry date as only 1 minute. So if we do this, we are going to receive an exception, right? The exception, the error message is the lifetime validation failed. Token has expired. So let's generate another one by trigger this authenticate API, right? So now I have this. Looks pretty similar, but it's actually not the same. What's different is the third part where it contains this part, the signature, right? So because the algorithm is the same, the user information is the same. So this first proof part looks the same as before, but this is different. Every time you call it, it's different, right? That's because the timestamp changed. So I'm copying this, and then I'm going to, actually, probably I talked too much. So let's actually regenerate this again, just to make sure we have a valid token. And I'm going to copy this again, and I'm going to come over here and replace this. Remember, this is a custom JSON web token authentication scenario, right? So that's why I don't need to put the barrier at the beginning. But let's see how this goes first, right? So, okay. So it says, now it returns the information that we're expecting, right? Because if we look at the version 2 and we scroll down to this, right? So lots of products, product ID and status, where we were providing the URL product ID is 1, the status is false, right? Because we didn't provide any information for the status. What I also want to try is, what if I modify the information here? So I'm going to generate the token. I'm going to copy this and paste it over here. And if I trigger it right now, it works, right? But if we go over here and then we modify some information, right? And we copy this first 2 part and paste it over here, replace the first 2 part. Now, if we trigger it, we'll receive an exception, and it's going to say signature validation failed, right? So if there's someone who trying to steal this token and modify the token a little bit so that they wanted to, instead of claim it's the original user, they want to use their own user, for example, then this signature validation will fail. It looks like we just changed a different way to verify the token. So we still have the token manager, still have the 3 different methods, just as before. Looks like we haven't achieved the self-verification, right? That's because we are using this custom created token manager and using the authorization filter, right? So if we, again, review the code, we are not storing the token generated anywhere. We're just verifying the token right here. It does not need to store the created token and compare the token with the token in the request header. So therefore, this is not necessarily have to be inside the token manager, right? We only need the authentication endpoint to generate a token. We do not need verify token to be inside the token manager, right? So this allows us to implement a single sign-on, right? Because as long as every web API server shares the same secret key, then they can use the token handler to verify the token. And we'll see this in the next episode where I configure ASP.NET Core to do the verification. All right, that's everything I want to cover in this episode. And in the next one, we are going to see how we can use ASP.NET Core way to implement a token authentication, right? Where we actually configure the middleware pipeline and the configure services method. In the configure services method, we're going to configure the barrier token. I'll see you in the next episode. If you like my tutorials, please give it a like and subscribe my channel so that you don't miss the next episode. And thank you very much for watching. I'll see you in the next one.